Hey everyone, in this video we'll continue on with the SageMaker inference series, and we'll specifically be building on the multi-model options that we were talking about in the previous part. I'll link that down below. But what we'll specifically do is we talked of two different options, right? Multi-model endpoints and inference components. In today's video, we'll specifically look at multi-model endpoints, the primary of those options, and we'll look at a CPU-based use case. There's also GPU examples that we'll get into later in the series, but we'll talk of how exactly do these multi-model endpoints work underneath the hood. Some sample use cases that you might see in the real world, because like always, I want you to be able to really understand when and where you can use these different features in a real world setting. And then we'll get hands-on. That same scikit-learn model that we've been working with this entire series, we'll make 300 copies of that specifically and deploy it behind this multi-model endpoint just to kind of showcase how you can have hundreds of models behind this feature. Before we can get in hands-on though, like always, let me start sharing my screen for my whiteboard right here. And let's just dive in for a few minutes into what MME specifically entails and then different places that you can use it, which we addressed a little beforehand. So if we remember in a traditional single model endpoint for SageMaker, there's a few different features. There's one, which is the model data. And if we remember, this lies in S3. And then two, we have the container, which is essentially the model serving stack. And like we said, there's different containers depending on your use case. There's torch serve, there's TensorFlow serving. We specifically in this example use DJL serving, which is the built-in in-house Amazon container, and we'll explain why later in terms of some of the benefits there. But as we remember, this container image, whether you're bringing your own or if you're using one of the managed available images, which is what we recommend, it's stored in ECR. Then three, there's the compute layer, which is just the hardware, right? So there might be CPUs or GPU-based instances. For MME specifically, we'll explore CPU in this use case. The reason we will talk about GPU in another video is there's only a few specific containers that support this for MME, that support the MME constructs at the moment, which are torch serve and Trident. But we'll get into this a little more later in another kind of video in this series. But here we'll take our DJL serving container and we'll go over a CPU use case. This is all going to stay consistent in MME. So you can imagine these two are basically the same. But what changes here is with the model data, keep in mind we now have hundreds of model artifacts. And if you remember, for our model data, we were creating a model.tar.gz, right? For which kind of encapsulated all of our different artifacts, including our model data and any inference scripts, any serving files that we might have been dealing with. For MME, the difference with model data is you need to provide a S3 path, which contains all these artifacts. So you need a common S3 path, which contains all these different artifacts in the same location. And you can imagine this as, right, let's say you have your S3 bucket, locations, let's say subfolder, whatever it is, your subfolder, whatever it is. And here you might have tar1.gz, tar2.gz, tar3.gz, tar4.gz, on and on. All of these lie in the same kind of S3 path. And MME, as we talked about lightly beforehand, where it becomes really, really powerful is it can control the loading of these models in and out of memory. So every instance or compute you have behind the endpoint, right, there's some sort of memory, so some amount of memory associated with it. What MME does is it takes all these models. Let's say you're invoking this model or this model. Depending on what's being hit in these different models, it will dynamically load them in and out of memory. So let's say you're hitting tar1 a lot. What MME does is it dynamically for you loads this into memory and it will make more copies of this model across your compute instances if it notices that it's receiving a lot of different traffic. And then let's say tar2 is never hit, then it gets unloaded out of memory and that frees up some space on your instance, right? So the kind of managed part of MME that you really want to take away from this is there is dynamic loading and unloading of models in and out of memory. And that's a very, very powerful feature, right? That you don't have to build or manage yourself. And then there's also model copy scaling. And this is where we'll explore a specific feature in our hands-on known as loaded model count. This is a metric specifically within SageMaker multi-model endpoints. But you can imagine, right, if A is being hit a lot, the copies for this are also going to increase a good amount. So that's where MME becomes really, really powerful, where you might not necessarily know the traffic pattern, but it will manage kind of that loading and unloading of those models in and out of memory, right? Um, and like we said, inference components is normally a better option if you have fewer models, but also more importantly, you know your traffic pattern. If you know which models you need to scale yourself and you want that control and flexibility, it's better to go to the inference component route. And we'll talk about that more in that video as well. And specifically, right, I think the next thing I did want to cover here within MME, there's this managed portion. There's still also the other components enabled in terms of serving and scaling. So you can enable whatever container of your choice. You can bring your own also if you want to, but in this case, we'll use DGL serving as we alluded to earlier. And specifically, you need to find a container that supports the MME constructs within the managed images. For CPU, there's a wide set of it, but like we said, within GPU, at the moment, it's Trident and TorchServe, which supports this MME feature. And then at the hardware level, right, there is auto scaling enabled. We won't really go into that in this case. Auto scaling enabled at the endpoint level itself. So just like we defined it in our single model endpoint auto scaling policy, you can also define it here with different metrics such as invocations per instance, things of that sort, right? And obviously it works a little different underneath the hood because there's multiple models that you have to distribute across these instances, but that's once again where that managed layer really kind of comes into play. Now that we have a bit of understanding of what MME itself is and how it is, and if you have any confusion, don't worry. In the hands-on, hopefully it becomes a little more clear the differences from single model endpoints and what we're enabling here. But if we go into our use cases, right, just to have an idea before we get hands-on, really anything where you have a personalization use case across many different users. So let's say Amazon, for example, has different shopping carts that it wants to tailor for each and every user based off their kind of previous orders. You might train your model on those different orders, and then you might have a model per user. Other things might be kind of if you have different providers and you have some custom models across each provider. Things of that sort. And use cases maybe such as login detection or things of that sort. Or maybe you might have some computer vision models that you personalize. Or like avatars, digital avatars. Those are some use cases I've seen. Just these are all kind of different dummy use cases that you can think of, but the main takeaway you want is when there's heavy sets of personalization / customization for a model across many different users. That's normally a good use case for MME. And in general, MME performs pretty well when the models are similarly sized and the traffic is normally evenly distributed, but we can also adjust for this at the serving layer where we enable there to be per worker per model scaling at the serving layer itself with DGL, and I'll talk about that a little more in specific. But in general, some of the patterns we noticed within MME are when you have models of similar size, it allows for more consistent kind of latency or throughput metrics, especially because loading a larger model into memory versus a much smaller model, as you can imagine, there will be a bit of a difference in that sense. So with that being said, right, why don't we get directly hands-on like usual in terms of working with this sample? What we'll do is let me hop back into the console. I'll get out of the slides right here. And sorry if I sound a bit under the weather at the moment, but right here we'll go to SageMaker AI, our usual console space right here. I'm going to be working in that same notebook I've been using for this entire series. You can also use Studio, you can use your local environment, wherever it is. Just be careful not to make all those 300 copies of the model locally in terms of where you're working. But yeah, if we go here, we'll go into SageMaker notebook instance right here. I've added a part 5. It's in the same GitHub that we've been working in. I'll link it down below as always. What we're going to do in this use case is we're going to take that same scikit-learn linear regression model that we were working with, and we're going to make 300 copies of this model. So 300 different unique tarballs. Obviously, in a real world use case, it's not going to be the same model artifact. These are going to be different ones, but I just want to show like a demo here or kind of the functionality here. And like I said, with MME, with GPU, we'll get into this a little later in a follow-up. But in this environment, right, I'm going to be using the same tools that we've consistently seen, the higher level SageMaker Python SDK, the lower level Boto 3 SDK, which lets me work with S3, SageMaker, any AWS services. I upgrade those and install them, and I set up my usual clients to be able to work with SageMaker, and that same client to be able to invoke the SageMaker endpoint as well. And I'll show the difference in invoking a MME-based endpoint in a second. Now here, same stuff as a single model endpoint. We're going to make that model artifact. I have my local model, which is training my scikit-learn model right here, and generates that joblib file. I then encapsulate all these different artifacts into that model.tar.gz format that SageMaker expects. And now here, the key difference is I'm going to make 300 copies of this model. So 300 different tarball artifacts in that same S3 path. So this might take a second to run. And I'm going to upload using that S3 Boto 3 client all these different artifacts into the same location. And this might be easier to visualize. So if I go to inference, I go to endpoints, I see my multi-model endpoint, which I already pre-created. But if I go to settings, I think here we have the model, which is the first step in the chain. We'll talk in a second. If we go to this model and I click this model data location, the difference from a single model endpoint here is that we have all these different tarballs now, right? And notice that they're all in the same path, but I have all these different tarballs, and obviously in a real world setting, these will be different artifacts, but I have all these different copies that I created and that I made here that you can work with essentially. So that's what this line in this notebook's doing. It's making these 300 different copies. I'm just adding a delimiter here to distinguish each model from its own, because if all of them are just sklearn.tar.gz, there's no way to know which model you want to invoke. So I made it 1, 2, 3. You can name it whatever kind of way you want or whatever makes sense for your application. We see that this is the S3 path. And just like we saw in the UI, we can verify that all those artifacts are there with the little shell command right here using the command line for AWS. And we'll see that all these different model artifacts are populated there. So we now have 300 different models that we can invoke, and each of them are uniquely named for us to be able to identify which one we're essentially invoking when it comes to that. Now, it's the same 3 steps as a single model endpoint. We're going to have the SageMaker model creation, which points towards your serving stack or your container and your model data location. And here we see that we're using DGL once again. And the reason we use DGL is we don't need to get too into the nitty gritty. This server, what's unique about it is it enables worker scaling for each model at the serving layer itself. So if you have a certain amount of compute behind the instance, there's a number of CPU workers that are built in for each instance. What DGL does is it dynamically scales the amount of workers or CPU cores accessible to be able to work with your model artifact depending on the amount of traffic that's coming to each model artifact. So if your traffic patterns varies from that even distribution where, let's say, just one model is receiving a lot of the traffic, what DGL will do underneath the hood is it will scale the number of workers or cores available to work for that model itself, that are available for that model itself. And that obviously can help you scale kind of or handle bursts in traffic if your traffic pattern changes. And it will make you more traffic pattern agnostic, essentially. But we don't need to get too in depth there. I just recommend using this serving container just because we have that flexibility built in. No need to fully understand more in depth what exactly is happening there. But if you would like to, I've attached this blog right here for load testing MME with DGL as a container. We go a little more in depth basically about that per model worker scaling and the benefits of using this as a serving stack. But here, right, getting back to MME itself, we'll see that we create the model object. The main difference is, along with specifying the image URI and model data, we specify the mode to be multi-model. So this is how SageMaker is going to know okay, this endpoint is actually a multi-model endpoint. We create that model resource. That's what we were seeing there. And our endpoint configuration, once again, is just going to be the compute that we want behind it, any different production variants that we might have for any A/B or shadow testing. And here I enable a C5D 4x large with 2 instances. To decide the compute behind MME, just like single model endpoints, you should load test. Another consideration you should think of is what is the memory that I have behind the instance? Because essentially, as we talked of, right, with MME, we can load models in and out of memory, but if there's ever a time that you're loading all your models into memory at the same time, you want to ensure that your instance has that sufficient available memory space to be able to hold that many models. Here in this case, these are very small. So I just took a C5D 4x large, which I think has 32 gigs of RAM behind it. I need to double check that. And I added 2 instances for it. You might need a limit increase request there. Honestly, we might have been able to fit all of these onto just one instance just because they're so small. But if you do want to follow this end-to-end, you might have to put a limit increase request, which is, you can find this in the service quotas tab right here in the console. Like I said, this is not a set formula for the compute. Definitely load test, understand your model sizes, and understand your traffic patterns in terms of what might be loaded into memory all at once, and play it a little safe here just so you don't run into any errors. But here we create that endpoint configuration, and then the last step, as always, is creating that persistent REST endpoint itself. We feed in our endpoint config, which is pointing our model into our endpoint. We create this, which might take a few minutes. And now we can finally invoke our model, right? And you should also see this in your endpoints tab here, as we saw with your SageMaker endpoints. The key change with this invoke endpoint API call, which is the same thing that we've been working with, is we specify our target model, which is going to be that S3 name of that file with the model data. So if I say 290 right here, great, that works. Let's say maybe 100. We can see that. And you might notice when you first run this notebook, there's a bit of a cold start when you're invoking this endpoint. And that's because this model is still getting loaded into memory. Once it's loaded into memory, you should see pretty quick inference speed there, obviously. But there might be a initial cold start for when you're first loading this into memory. And then we can see here, right, I just made a bit of a loop where I'm just randomly picking from the 300 models, and I'm invoking different target models here. So you can play around with this just to get a better feel. And just a very, very quick last thing before we call it wraps on this video is, if we go to our endpoint and we see the different metrics that are enabled, you'll notice for MME, and it might not be here itself, but I'll attach this. I don't think it's built in here, but if we see loaded model count, you guys saw my search history there. It was not anything too bad, but if we go to load model count, multi-model endpoints, AWS, you'll see there's CloudWatch metrics for multi-model endpoints. And right here, there's different metrics that you can look, such as the loading time for that target model to be downloaded or things of that sort. And these are different things that you can also take a look at to better understand what exactly is happening underneath the hood. And the key metric that I was referencing, loaded model count, right, is the number of models that are loaded in these containers. And the reason this might be greater than 300, right? If you see this metric is, and this is what I was confused by when I first was new to MME, is there might be a higher loaded model count than the number of models you have behind the endpoint itself. Because if we remember, MME will dynamically make more model copies if a model's getting very popular or hit, and distribute that across the instances behind your endpoint. So let's say model A is getting hit very frequently. You might make copies of model A onto maybe instances 2, 3, 4, or whatever it is, dynamically underneath the hood. So if you ever see this being higher than the amount of models you actually have, don't worry. It might even be lower than the amount of models you have. Some of them might not be getting hit, and they might be unloaded out of memory. So this is a good way to understand how many model copies you actually have loaded in and out of memory behind the endpoint itself. And don't mix this up with the serving layer with DGL. That per worker scaling or per model worker scaling that we were talking about is at the serving layer in terms of the allocation of the CPU resources itself. So don't mix that up. The copies MME is making is the actual models which are getting loaded into each instance's memory in and out. So two little separate things there. Don't get too mixed up there. Just know that MME is dynamically scaling these models in and out of memory for you. Dynamically loading these models in and out of memory for you and scaling the copy count or loaded model count as needed. So yeah, I think that was a bit of a wrap for today's session itself today. I hope it was a good guide for understanding multi-model endpoints. I know it can get a little nitty-gritty, so just take a stab at running this end-to-end. What we'll do in our coming videos is we'll talk about GPU-based endpoints for MME, because there's some nuances to that in terms of understanding the servers that or containers that support MME constructs. And after that, we'll get into inference components, which is the second kind of multi-model hosting option that exists within SageMaker. I know there's a lot of different ones, but what we'll try to do is try to make sure there's a hands-on for each and every single one of these, just so you can understand by yourself while working with it. But thank you as always for watching. If you enjoyed this video, please feel free to leave a like and subscribe to the channel. And any questions, please follow up on one-on-one with me, be it the comments, LinkedIn, or Twitter, anywhere else. But thank you as always, and we will be back very, very soon.